Now, for the rhombus and the kite, their areas are related to the lengths of their diagonals, which, if you remember, is kind of nice because they're perpendicular to each other, so we get right triangle stuff again. But all we need to know is the diagonals, find their product, and cut it in half. So let's say diagonal 1 on this rhombus here is 5, and diagonal 2 is 4. That means the area of that uh, rhombus is 1 half 5 times 4. Doesn't that look really similar to the triangle theorem? Except instead of using base and height, I'm using uh, uh, diagonals. Yeah, yeah. Uh, half of 4 is 2 times 5 is 10. So that would be your area here. So that's all we're going to do. So the only trick for these is going to be finding the correct lengths of the diagonals. You might have to do some geometry or algebra to figure those out. All right. Example 3. Area of a rhombus and a kite. So in part A, I have a kite, but it doesn't matter. The area for both of these things is 1 half uh, diagonal 1 times diagonal 2. And if you notice here, I've got diagonal 1 and diagonal 2 already spelled out for me. So this kite is going to be 1 half times 8 times 15, or 4 times 15, which is 60. So the area is 60 meters squared. For part B, there's a little bit more to figure out. It tells me this bottom left portion is 12 feet long, so the top right portion should also be 12. And then for the bottom right, I have 10, so the top left should also be 10, which gives me the diagonal 1 is 20 feet long, and diagonal 2 is 24 feet long, so the area equals 1 half times 20 times 24. Half of 20 is 10 times 24, that's 240 feet squared. So once you get it plugged into the formula, it goes pretty fast. It's just some basic calculations.